Welcome, ladies and gentlemen. May I have your attention, please? Thank you. Let's go ahead and take a look at our Bellwork questions today. We need to be able to determine the appropriate strategy to use to find a missing side or missing angle, right, in our given triangle. So as I take a look at the first one, I want to consider, right, our flow chart we discussed last time. Is there a right angle? If there is, it opens up all those possibilities for right triangle trig, like Pythagorean theorem, right? SOHCAHTOA. And so those are going to be the most efficient methods for solving if I have a right angle. And it looks like that's the case for number 1 and number 2. All right, go ahead and tell the class then what trig function you use to solve number 1, given that our reference angle is 37 degrees, right? 10 is adjacent 37 degrees, and x is the hypotenuse length. What trig function did you use? In
Cosine.
Cosine, raise your hand if you use cosine. Cosine function, absolutely. So cosine of an angle, thank you, is a ratio. In this case, our angle is 37 degrees, and our ratio is adjacent side length to hypotenuse length. For us, that's 10 centimeters to x, my unknown. Depending upon where my unknown is, we'll use a different series of inverse operations to solve. What strategy do I use to get that x out of the denominator? What can I do to get that x out of the denominator? Cody? Thank you. We'll multiply both sides by x, and that will get the variable expression out of the denominator and on a level playing field where we can solve for it. So I get x times cosine 37 degrees equals 10, and I can finish it out by division. So I'll go ahead and divide both sides by cosine of 37 degrees. And we get x by itself. It looks like x is exactly 10 divided by cosine of 37 degrees, but I don't know what that is, so I'll get an approximation using the calculator. Make sure that you're in degree mode, please, if you're given degree measures that are, angle measures that are in degrees. And we'll get an approximation by doing 10 divided by cosine of 37 degrees, close angle. Raise your hand if you had about 12.52. 12.52. And what's the label on that? The label on that, Chrissy?
Centimeters.
Centimeters, awesome, thanks. 12.52 centimeters. Uh-oh. 12.52. Awesome. Let's take a look at the second one. What trig function relates my angle theta, 7 furlongs, and 15 furlongs? What trig function are we going to use there? Taylor? Tangent. Raise your hand if you had tangent for number 2. A tangent function. Good job. Thank you. Tangent of an angle is a ratio. In this case, my angle is my unknown measure, theta, and my ratio is opposite over hypotenuse. Opposite over adjacent. So for us, that's 7 over 15. Go ahead and tell the class what undoes the tangent function to solve for a missing angle, right? What do I do to undo that tangent and get theta alone? Aaron?
Inverse tangent.
Inverse tangent, absolutely, thank you. So if tangent of theta equals blah, then theta equals the inverse tangent of blah. It just so happens that my blah was the ratio 7 to 15, so I'll go to the calculator and get an approximation for that. If I'm in degree mode, it'll spit out, right, a degree measure for that angle. So inverse tangent of 7/15. I get about 25 degrees. Raise your hand, get about 25 degrees. 25 degrees, yeah. And I'll take a screenshot of that for PDF ability. That's what we're talking about. Awesome. What questions do you have about 1 or 2? So right triangle trigonometry, right? That's in our comfort zone. We're good dealing with right triangle trig. What about if we take away that right angle, all right, and open up our discussion to include, right, non-right triangles? Now we've got some more tools. We've got law of sines and law of cosines, which will hold true for any triangle, regardless if I have a right angle or not. Let's consider the strategy for use in number 3. When there's no right angle, I ask myself, do I have an opposite side angle pair? If I know information about an opposite side angle pair, then I'll be able to fill up one of the fractions in my law of sines, and that'll be my tool. Do we have information to complete an opposite side angle pairing? Do we know measures of a opposite side angle pairing in this case? Blake? No, we don't. So can we use law of sines? No, we can't. We've got to go all the way to law of cosines, which looks like the trickiest form, but it's pretty easy actually to find an unknown side length with law of cosines. It's a one-stepper, right? We just have to solve for our side length. And so let's go ahead and set it up. I don't care that I don't have A's, B's, or C's. I could take my general form. A squared equals B squared plus C squared minus 2 times B times C times the cosine of angle A, and rewrite it with any side length substituted in. What's key is that my side length that's isolated, right, it corresponds to my angle measure. That's an opposite side angle pair, right? And so that drives the problem whether we're dealing with law of sines or law of cosines. I'm looking to find that opposite side angle pairing. That determines my placement. All right, so I don't have A, I don't have B, I don't have C. I have unknown side length, X. So I'll go ahead and start out with X as my side length squared because I have the angle that's opposite that side X. This is the form I'll use. So here we go. X squared equals, what's B, what's C? It doesn't matter, they're the other two side lengths squared. So I could do 11 squared plus 12 squared minus 2 times 11 times 12 times the cosine of 71 degrees. So it doesn't matter that we had X's there instead of A's and B's and C's. We're still going to be able to use law of cosines to solve. 70 even? Sorry, thank you. 70. Thank you, Jacques. It's be tough having me as a teacher. It's like, take one step, drag Mr. Fritz. Take one step, drag Mr. Fritz. Slowing you guys down. Sorry, my bad. Thank you. So this is subtraction symbol too. I want to make sure. Great. So now how do we solve for X? Easy. Even though this is a whole bunch of complicated mess on the right, I can solve for X in one step, right? If I want to find side length X, I just have to undo squaring, and we know we take the positive negative square root. But because we're dealing with a side length, I don't even need to consider the negative square root in this instance. So we'll go right to our answer. I know X is given by the square root of 11 squared plus 12 squared minus 2 times 11 times 12 times the cosine of 70 degrees. And we'll see what our calculator says for that. So the square root of 11 squared plus 12 squared minus 2 times 11 times 12 times cosine of 70 degrees. Close angle. Close radical. Voila! About 13.22. Raise your hand if you had 13.22 feet. 13.22 feet. Way to go, you guys. Awesome work. And let's take a look at number 4. Do I have an opposite side angle pairing? Right? Do I know information about an opposite side angle pairing to complete one of my fractions? Do I have that information? Andrew?
Yeah.
Yes, I know 38 degrees is this lower right acute angle, and that's opposite 14 centimeters, so I could fill up one of my fractions, which means I can use law of sines, which is simpler looking than that. And so we can use law of sines in order to solve for my unknown side length B. It's just that we must first see what angle measure is opposite B, and because we have 2 angles already, we can get the third one for free. The interior angles of any triangle sum to 180. So we can get this angle measure by doing 180 minus 72 minus 38 equals this angle measure, and fill that in. So it looks like that's 100, 110 from 180 is 70. Are you using 70 degrees? Woohoo! Now we're all set. Let's use law of sines. I have the choice of putting sine of an angle on top or side length on top. If my unknown is a side length, I'm going to purposely start with that on top because it'll be one less step to solve. So everybody, B is to the sine of 70 degrees, just like 14 is to the sine of 38 degrees. We've purposely chosen to put my unknown side length, circled B in green, on top of my law of sines form. Now I can solve by one step. I'll multiply both sides by sine of 70 degrees. That's going to get b alone in one step. So we'll times both sides by sine of 70 degrees, and we'll get b by itself. B is going to equal 14 times the sine of 70 degrees, closed angle input, all over sine of 38 degrees. Again, I don't know what that is, so I'll go to a decimal approximation and get 14 sine of 70 degrees, close angle, all over sine of 38 degrees, close angle, and I get about 21.4 degree, nope, 21.4 centimeters. Raise your hand if you got that. Did anybody get all the way to 21.4? Hey, good job, you guys. Great. So that's about awesome. What kinds of questions do you have about 3 and 4? About 3 and 4. Okay, 2 to go, you guys. Stay strong. In my opinion, 5 is the trickiest kind of question. The trickiest one that you'll have to do on your first quiz in Unit 8 for trigonometry, where I have to find a missing angle measure utilizing law of cosines. I must use law of cosines in number 5 because there's no opposite side angle pairing. If I'm only given information about side lengths, right, and I don't have any angles, then I don't have any opposite side angle pairs, which means I can't fill up a fraction in law of sines. It's time to go to law of cosines. What law of cosines do I want? Well, remember, right, we've got 3 different forms. One of them was c squared equals a squared b squared minus 2 times a times b times the cosine of angle c. But as I look at my picture, I don't have a's or b's or c's. In fact, I've got a y. Right? I've got a y up here. Well, the y is my angle. So I'll just go ahead and make sure that it's cosine of angle y, not cosine of angle c. Yes? And then I need to make sure that the opposite side, in this case c, corresponds to cosine of angle c, just like y corresponds to side length 4 meters. So we'll start off not with 11, not with 9, but with 4 squared is opposite my angle. Equals the sum of the squares the other side, 9 squared plus 11 squared minus 2 times 9 times 11 times the cosine of y. Now, depending on where y is, we'll use different operations to solve for it. This is my trickiest kind. I need to find an angle measure using law of cosines, and it's hidden right here in my cosine function. So I've got to do lots of work. Instead of pressing enter every time on my calculator and running the risk of messing up the inverse order of operations, I'm just going to solve algebraically and not simplify anything, and then at the very end go to the grapher once and do one entry. Right? I'm going to be less likely to make a mistake. You'll have to find your own comfort zone in order to generate the correct answer. On the quiz, I want everybody to know in advance that you won't be able to ask me, right, how to enter this in your calculator. That's what we're quizzing you to see, so you can find this measure on your own. And so I'm going to go ahead and isolate that cosine of y first by subtracting over the 9 squared, subtracting over the 11 squared. I can't add over the 2 times 9 times 11 because it's connected with multiplication, right? So I can't just add over that plus 2 times 9 times 11 the way that I could subtract over this 9 squared. It's connected to my unknown term by multiplication, so that's stuck. I've got to use division. In order to get that cosine y term alone. I'm going to divide both sides by negative 2 times 9 times 11. That way, cosine y alone. Cosine y is given by 4 squared minus 9 squared minus 11 squared all over negative 2 times 9 times 11. Gosh, and we're so close I can almost taste it. And yet we haven't solved for angle y. We've just isolated the cosine of angle y. So how are we going to finish this out and get my unknown angle y alone? Rachel?
Inverse of cosine.
Absolutely. If cosine of y equals blah, then angle y equals the inverse cosine of blah. Big parentheses. Holy cow. Those are some huge parentheses. Yes, they are, because we've got a lot of stuff to fit in there. We've got a numerator. A numerator given by 4 squared minus 9 squared minus 11 squared. We've got a denominator given by the opposite of 2 times 9 times 11. And we've got a calculator that's going to give us an approximation for that. So here we go. Inverse cosine. Oh my gosh. Open left paren. There's my numerator. Open my numerator. 4 squared minus 9 squared. I don't want to play. I want to play 4 squared. Minus 11 squared. Closed numerator. Divided by open denominator. Negative 2 times 9 times 11. Closed denominator. Double it. Close inverse cosine. Throw a pinch of salt over the shoulder, and voila! I get about 20.05 degrees. About 20.05 degrees. If you're getting an error, check the number of parentheses. I tried to color code them so you can see exactly, right, exactly what we need to enter in a calculator so that we don't get an error. This time my label is not centimeters, it's not feet, it is degrees. We found an unknown angle measure. Awesome. What questions do you have about 5? That's the trickiest one. Alright, then let's finish it out with on the downhill. We can find unknown side length A because we already know an opposite side angle pairing. Notice how our 47 inches is opposite 63 degrees, so we can fill up a fraction of my law of sines. Start off with my unknown measure on top. A is to the sine of 56 degrees, just like 47 inches is to the sine of 63 degrees. And this is a one-stepper. We can solve by multiplying both sides by sine of 56 degrees to isolate the A. What does A equal? A equals 47 times the sine of 56 degrees, all over sine of 63 degrees. And we'll go to the grapher one more time before taking a screenshot. I get 47 times the sine of 56 degrees, close angle input. Didn't want to hit clear. 47 times the sine of 56 degrees, close angle input. I want to hit divide. Sine of 63 degrees, close angle input. And about 43.7 inches. 43.7. Raise your hand if you got that for the last one. And we get that for number 6, law of sines. Law of sines is more straightforward compared to law of cosines. Pretty sweet, yo. Awesome. What questions do you guys have about today's Bellwork? Okay, we'll go ahead and remind us about the flowchart. If you guys take a look at the last page, we've got a completed copy for you. I would encourage you to utilize this flowchart, not just today when we practice with our Trig Applications Packet a little bit later, but also when you attempt your quiz problems where you have to find missing sides and angles. Just consider, do I have a right triangle? If I do have a right triangle, it opens up all the possibilities of right triangle trig, like SOHCAHTOA, Pythagorean theorem, special triangles even. Versus no, if I don't have a right triangle, then I've got to use law of sines or law of cosines. But if I have an opposite side angle pairing, I can use the simpler law of sines as opposed to the more complicated law of cosines. I'll reserve that for when I don't have an opposite side angle pairing or can't get one by doing my 180 minus strategy Jacques showed last time. All right, we're going to go ahead and pause the recording as we check our homework number 2. Okay, ladies and gentlemen, at this time I'd ask that you find your green sheet. We're going to go ahead and pin down a nice solid example for law of sines, law of cosines, practice with a couple different cases in which we're given opposite side angle pairings or not, and then we'll have an opportunity to practice. You'll be able to work on your Trig Applications Packet quietly, either by yourself or with another classmate, so that you can practice and solidify this new learning. I know law of sines and law of cosines is brand new, but very powerful. So, for any triangle, right, we don't have to have a right angle. We know that the side length A is to the sine of angle A, just like side length B is to the sine of angle B, and so on. We could rearrange our law of sines depending upon what we're looking for to include the sine of angle on top and the side lengths on bottom. We'll choose the most appropriate form based on what we're looking for. If I'm looking for a side length, I'll go ahead and use one of the top ratios to start the party in my equation. If I'm looking for an unknown angle measure, then I'll go ahead and use one of those second row ratios to start my equation. And these ratios were included on your day 2 note sheet as well. Hans?
Will we be allowed to use these on tests?
You'll be given one form, so you'll be given one proportion. You won't get 3 connected in a row, you'll get 2, but it could be any letters. The same is true for law of cosines. We'll give you one form for law of cosines, right? But it might be different letters than the letters that are on your triangles on your quiz. You see what I'm saying? What's the key then? How do you keep it straight? Well, the opposite side angle pairing are bookends for your law of cosines. Just like your opposite side angle pairing make up a single fraction in law of sines. So it doesn't matter that we have A, right, B, and C. The angle measure is opposite the side length squared, right? That's the one that's isolated. So let's go ahead and rearrange it in our 3 forms. If A squared is given by B squared plus C squared minus twice the product of BC times cosine of angle A, we could have just as easily had B squared isolated. Then what angle would we be dealing with? We'd be dealing with angle B, right? The B's would be my bookends for my law of cosines, and my other side lengths would be the other 2 sides. That would be A squared plus C squared. So here we go. A squared plus C squared minus 2 times A times C times the cosine of angle B. That's not all. Go gadget on. We could have just as easily had, you guessed it, C side length squared isolated on one side, set equal to the sum of the squares of the others. Now it's A squared plus B squared are the other 2 side lengths squared, minus twice the product of AB times the cosine of angle C. So it's important that you're able to rearrange that, and you saw that on one of your homework exercises last night. A couple of them had like P, Q, and R, right? Or P squared, R squared, Q squared, or whatever, and you had to see what would that be equivalent to. Awesome. Everybody have the forms? So you'll be given one of these. Right? You'll be given one of these, and you would have to rearrange it based on the information in the problem. Cool? Great. Let's go ahead and take a look at our first case. So in our first example, we could find side length AB in the given triangle. Label that our unknown x by considering the presence of an opposite side angle pairing. Do we know an opposite side angle pairing? Certainly. We see that 15 centimeters is directly opposite the angle A, which measures 46 degrees. Therefore, this problem can be solved using law of sines, and that's simpler, right, in its form than law of cosine. So we'll start off with a ratio. I choose to put my unknown on top, unknown side length on top. So I'll do x is to sine of 85 degrees, just like 15 is to sine of 46 degrees. So everybody start off with our law of sines ratio. We can then solve in one step, just like our Bellwork, because we placed our unknown side length on top, we can solve in one step simply by multiplying both sides by sine of 85 degrees. And in so doing, we could get our exact answer. X is given by 15 times the sine of 85 degrees all over the sine of 46 degrees, which is approximately 20.77 centimeters. So we've got a solid law of sines example now, when my unknown is a side length, and I'm given an opposite side angle pairing directly. Please take a look at our second example. If we're asked to find CB, I'll label that as my side length x. I'll start with the same questions. Do I have a right angle? No, this is an obtuse triangle, so I can't have a right angle in it. In fact, angle A measures 100 degrees. Do I have an opposite side angle pairing? If so, I could utilize law of sines. Take a look at my picture. Do I have an opposite side angle pairing, Will? No, I don't. And so what do I have to use? My final tool, law of cosines. Law of cosines has a squared or b squared or c squared, and I don't see any of that here. Well, I do. I guess a, b, and c are my angles, so we'll start off with my unknown side length is opposite angle a, so my x, right, would be the a in that first law of cosines form. So we'll start off with underlined, right, underlined x squared equals, and then it doesn't matter which comes next, we'll do 80 squared plus 72 squared minus twice the product of 80 and 72 times the cosine of 100 degrees, the angle opposite my unknown side length that's isolated. That's quite possibly the worst angle arc I've ever drawn in my life. I apologize for having exposed you to it. Good catch. And we can solve for x in one step by taking a square root. So we'll do the square root of that, just like we did in class. I'm going to write that down. And that's about 116.55 feet. In the third example, I'll start with my question, do I have a right angle? No. Do I have an opposite side angle pair? Well, if I'm trying to find BC, I'll label that side length x. I have enough information to complete an opposite side angle pairing because I have two given angle measures. Therefore, the third is free by doing 180 minus. So 180 minus the 125 minus the 21 equals angle C measured 34 degrees. Once I fill in my 34 degrees, I do have a complete opposite side angle pairing. I can now utilize law of sines to solve this triangle for missing side length BC, which I've labeled x. I'll start off with my unknown side length on top. X is 2, sine of 21 degrees, just like 97 is 2, sine of 34 degrees. This is a one-stepper. We can solve for our unknown side length x through multiplication. We can multiply both sides by sine of 21 degrees. In doing so, we'll isolate x. It's given by exactly 97 times the sine of 21 degrees, all over 34 degrees, which in turn is approximately 62.16 meters. And almost there, but what if we're looking for an unknown angle measure, right? An unknown angle measure where we're given 1, 2, 3 side lengths, but no angles. Well, we don't have an opposite side angle pairing. This is the trickiest one that you'll have to do on your quiz. Let's find an unknown angle measure utilizing law of cosine. So we'll start off with our initial form. The opposite side from angle B is 16 inches, so that's going to start the party. 16 squared equals the sum of the squares of the other leg lengths, or side lengths I should say, minus twice their product times the cosine of my unknown angle B. So let's rearrange that so we can solve. Right? I know that I need to isolate angle B, but first we've got to do some work. We'll do 16 squared minus 19 squared minus 22 squared. That equals the opposite of 2 times 19 times 22 times the cosine of angle B. Next, we'll isolate cosine B by dividing both sides. So we'll divide both sides. We'll divide both sides to undo that multiplication. What am I going to divide by? I'm going to divide both sides by negative 2 times 19 times 22. So cosine of angle B will be given by equal 16 squared minus 19 squared minus 22 squared all over the opposite of 2 times 19 times 22. Gosh, and we're so close. We can almost taste it. I know that my answer then will be given by angle B, which will be the inverse cosine of. The inverse cosine of, big parentheses. I'm going to have a numerator, pair of parentheses. I'm going to have a denominator, pair of parentheses. In my numerator, I'll have 16 squared minus 19 squared minus 22 squared. In my denominator, I'll have negative 2 times 19 times 22. And on my calculator, I'll have inverse cosine of, open up the numerator, 16 squared minus 19 squared minus 22 squared. Close numerator with the right paren, divided by, open the denominator, negative 2 times 19 times 22, close denominator, close inverse cosine. Voila! We generate about 45.2 degrees. Hey, that's pretty sweet. Awesome. Bless you. What questions do you guys have about your green sheet? Okay, so while you can't use the green sheet in its entirety, you'll be given one form of law of sines and one form of law of cosines, but you'd have to be able to determine when is appropriate to use which law based on the given information. To that end, we have our flow chart and our closure questions are aimed exactly at that. So we'll go ahead and write a response for each of our closure questions. When is it appropriate to use SOHCAHTOA? What information is necessary to use law of sines? And what information then is necessary to use law of cosines? I'm going to go ahead and pause the recording and give you a few minutes to write those in, and then we'll resume to share our answers with the whole class. Okay, go ahead and share with the class your response for closure when I call on you. When is it appropriate to use SOHCAHTOA to solve triangles? So when is it appropriate to use SOHCAHTOA? Mitch?
When there is a right triangle.
Absolutely. So when we're working with right triangles, then it's appropriate to use our SOHCAHTOA right triangle trig ratios. Good, thank you. What information is necessary in order to utilize our law of sines? Chloe?
What is the opposite side angle pair?
Good, thank you. We must know an opposite side angle pair in order to complete one of our fractions. Good, thank you. And lastly, if we don't know an opposite side angle pair, right, or we can't get one using our 180 minus strategy, then we must use law of cosines. So if we don't know an opposite side angle pairing, then we are left with law of cosines. Awesome work, you guys. So we've included this as part of your note sheet at the end, right? And you can utilize this as you work and attack these problems. You're going to use the rest of this class time, so a nice chunk of class time, to work on your homework assignment, Trig Applications Packet. Some of these are tricky to visualize, okay? First thing we want to do is draw a picture, label with given information in a variable, then write an equation. Based on our flow chart, you can determine which tool would be appropriate. You're going to solve for the unknown first, and then use your calculators last to find the numerical answer. Calculators should be in degree mode. Don't round your answers until the very end, so you don't lose accuracy. Include units with your answer. For a real-life problem in context, you're going to have units in the problem. And be sure your answers are reasonable. What I've done is I've taped my pictures and answer numbers on the back whiteboard and on the side whiteboard. So depending upon where you're sitting, you'll have easy access to go ahead and check. Sometimes you just need a kickstart with how to orient the picture, and then you'll be able to determine, right, which law would be most appropriate based on the given information. I'm going to go ahead and save the recording now, and you can go ahead and begin your work.